Yes. Yeah, here. Thank you, Tazeen. Midterm
Can
had a
you
riddle at
please
the end. Sorry?
can you please put the attendance link?
Yeah, let me put the link again. There, I just sent it in the chat. Someone asked me to class with the recursive. Only vectors. Yeah, the recursive tower of Hanoi includes the vectors. Sorry. Oh, I made a mistake. Not recursive, iterative. Thank you for that. Iterative. No, Fancy A Queens isn't going to be on it. It's just too long of a program to give you guys. Stable Marriage wasn't on mine, could be on yours. But again, we can also, I'll put it down to go over because I didn't do it for the midterm. But I doubt it'll be on your final. Is there going to be any binary on the exam? There could be one with binary addresses, just like how you did it before. Let me see. There was a riddle, okay. Am I missing anything else? And Queens, not to write the code at least.
Pointers, can you go over a little bit about pointers? You know how
pointers? Yeah, I can do pointers again. Do we go over the midterm review as well to practice for the final? You can go over the midterm review, yeah. There's a heavier emphasis on the material after the midterm, but there's still going to be some things from before the midterm. Okay, so we can do stable marriage first because I know I didn't do it last time. Does anybody else want me to go over something else before we start? Type def. What's big in T? Okay, let's go over stable marriage and then we'll knock out the rest of these. So, stable marriage. You have two conditions that make this true, right? And I think he gives it to you. He says, if the current man prefers, means he wants this over what he has now. Prefers the new woman to his partner. To his partner. And if the new woman prefers the current man to her partner, we have an instability. Just means return false. Okay. So let's get a couple of things down. Yeah, Tazine, I think you're talking about dynamic programming. We can go over those as well.
also he said something about Fibonacci. He said it's gonna be important. It's gonna
Yeah,
come.
Fibonacci has memorization. I think that's what he's talking about might be important for it. Okay. And we have an instability. Okay, let's write this code down then. So you have two tables. You have the men's preference and the woman's preference, right? Each is a 3 by 3 table. And remember, when he says you prefer somebody over somebody else, it means you have a lower number. Okay, so if the current man ranks the new woman as a 0 and the new woman ranks the current man as a 0, they want each other the most. Okay, they rank each other as the highest, essentially, even though they use the lowest numbers. So to say current man, we say C, and to say new woman, we say Q sub I. Okay? Be good. Yeah. Okay. So let's write this down. So we look at the man's preference. If the man's preference, the current man's preference, this is current man's preference, he is with the current woman, that's Q sub C. If that number is greater than the man's preference for the new woman, and we have to talk about the woman's preference now, the new woman is ranked higher than the new woman with the current man, we return false. Okay, let's break this code down really quickly. For the men's preference, the first position will always be the man. Either current or new. Current is C and new is I. Do we need a for loop before that? Yeah, you need a for loop before that. Good, that's the OK function. The OK function all stays the same except for these two conditions. It's the same thing as 8 queens, and the rest of the main function stays the same, except instead of 8, you just change it to 3. That's it. There's nothing else different here.
Isn't it supposed to be less than, because the values are like 0 is the highest, isn't it? In terms of preference?
Right. So I'm saying here, over here, this says if the current man, remember, because man is the first position, if the current man with the new woman is ranked lower, right? This means Pac-Man wants to go here. So this number has to be lower number than the current man. This is current man with the current woman. And here we go. This is the new woman. And this is the current man. Is less than, right? This is a lower number again. This is the new man. And this is the new woman. Okay? If these two are true, then we have to return false. Does that make sense? Okay, perfect. So again, just to break it down, for the men's preference, the first position will be the man, and then it'll either be C or I, current or new. And the second position will be the woman, which will be Q sub C for current or Q sub I for the new one. For the women's preference, it's going to be the woman first, which is again denoted by Q sub C for current, or Q sub I for new, followed by the man, which is going to be C or I. Okay, and the combination depends on what the if statement says. So here we said the current man and the new woman, so that's exactly what we have. We have the current man and the new woman, and the current man and the new woman. Okay? Perfect. Any questions? Okay. If not, let's do the second condition for stable marriage. Second condition says, if the new man prefers to be with the current woman to his partner, and if the current woman prefers the new man to her partner, we have an instability. Okay, so let's work on this one together. If I want to say if the new man prefers to be with the current woman, how do I say that? The new man. Talking about the man's preference now. So the new man, the first position is a man. How do I say new? With I. The new man prefers to be, let's do this way. The new man wants to be with the current woman. So Q sub C, right? They rank lower. The lower number, the higher. Let me see if that's right. I, Q sub C. Excellent, good. There's just no parentheses because it's a 2D array. Good. So I, Q sub C. He prefers that over his current partner. His current partner will be the same as him. So if he's new, then it's going to be the new woman. It's going to be Q sub I. Just like that. Okay, that's the first one. And the woman has to reciprocate this. If not, it's not unstable. It's just a one way. And the woman's preference, so she would be, we want the, somebody texting, no. We want to say the current woman. So let's get all this down. So we want to say the current woman prefers the new man, that's just I, to her current partner, which is going to be the current man. Then we return false. Okay. Any questions about that so far? Okay, perfect. So something like this, he might just ask you to write the OK function just like he did on the midterm. I haven't seen stable marriage on a midterm or final, so it might be a first, but it's good to know just in case he does ask. Okay, if there are no other questions, I'm going to move on to the next topic. I'm going to touch upon riddles first because that's just going to be the quickest one for us to deal with. His riddles tend to be ambiguous. Okay? That means a couple of things. Sometimes there are no answers, no ways to do it. Or sometimes there are many answers. There are many ways to do something. And so what his goal with that is, to try to get you to do the same thing you do in 8 Queens. You try many different options, right? But you use an algorithm. You do it in a certain organized fashion. If you do it in an organized fashion, you'll be able to see if there is or if there isn't an answer to this question. How many riddles are there in the exams usually? I want to say my lab professor said it was 50% of the exam. I think it's more, if there are 12 questions, I think maybe 4 or 5 of them are going to be riddles. Okay. Towers of Hanoi iterative. That one's a fill in the blank. It's worth 15 points. It's probably one of the easiest 15 points on the final. So I remember two riddles. The first one was the chessboard knight. Okay. He tells you start on a light square, and if you guys know how a chessboard looks, which I'm sure you do, it's alternating colors and alternating in the rows and the columns. Okay, so it's going to be, all the diagonals are going to be the same color essentially. So you start on a light square, and you can only move like a knight on the board. Okay, so that's the rule. What's the goal here? The goal: touch every square on the board exactly once. And the second condition, and end up on a light square. Okay? That's your goal. So the answer to this is it can't be done. Okay? Now, there's one reason that I remember, is because if you start on a light square and you move in an L formation, just like a knight, sorry, not a knight, the horse. What's the horse called? No, it is a knight, right? Yeah, the horse is a knight. Let me just put horse, just so you guys know what I'm talking about. So the knight can only move in an L-shaped formation. And if you work that program out, you'll see that you start at a white square and you go on a black square. And then the next one will be a white square, and the next one is a black square. So in order for you to get from one light square, touching every single square, and then end up on a light square, on another light square, you have to do one of two things. You either have to skip one black square, which means you only touch 63 tiles instead of 64, or you touch one light square twice, which means you've touched 65 tiles instead of 64 tiles. And that's, again, he doesn't expect you to know that and be able to do it when you're stressed out on the test, but I was able to figure it out after the final. I wasn't doing this on the final. It was one of the questions that I skipped. But it can be done. Again, if you missed it, it can't be done for 2 reasons. For one of 2 reasons. If you want to start on a light square and end on a light square, you're either going to touch 2 light squares, which means you didn't hit every square exactly once, or you're going to skip a black square and that means you still didn't touch every square on the board exactly once. You touched only 63 instead of 64. If you're right, cannot be done, we get full points. If it's Waxman, he'll probably ask you to explain it. Explain why it can't be done or why it can be done. He'll probably just say explain the solution instead. But if you can try it, I'm sure he'll still give you partial credit for saying it cannot be done. Okay. Then there are questions that he gives you that have many answers to it. And so I forgot the exact way he phrased it. So the riddles aren't coding based. Yeah. The riddles aren't coding based. They're more so based on logic. Exactly. Whether you can think through it correctly. Exactly. But again, he could change it for your final. I don't want to say this is 100% the case. He could change it for your final. The only difference, the only thing that I remember is that mine was completely logic based. Here's another one. He'll tell you, I forgot exactly how he phrased it, but he'll say Bob makes more money than John. John is related to Chris. Chris has 3 brothers. Something along these lines. He's gonna give you people. Yeah. It was the bang, the cousin with the bang. Exactly. Yeah. Okay. Oh, this was on the midterm? Oh, okay. Never mind then. So you guys already saw it. But yeah, he gave us something like that on the final. And essentially, at least our example, he said there was more than one answer to it, right? Because he left out some specific details, which made it seem that you can interpret the question so it could have been that he had many different versions of it if you didn't get it. What he did was he told us that because he left out some key points of information is that it was ambiguous. You were able to come up with many different answers as long as if you ran through the algorithm. You said you started with what you knew and then filled in the blanks from there. So yeah, that was just an example of the riddle. Okay, I'm glad he gave you something like that before. Okay, and Towers of Hanoi, we covered. That's just straight fill in the blanks. He's gonna say, let me see if I can get the code out. I'll tell you what I remember him asking you guys. Give me 1 second. Oh, here it is. Okay. In my book, it's page 62. I don't know if you guys have it. Let me see. Yeah, in my book, it's 62. Can you show us logic when you solve the cousin riddle? I didn't solve the cousin riddle on the final. He told us afterwards that there were multiple answers to it. I already gave a question one year. Knights and knaves. No, he didn't give us knights and knaves. The riddles is really the only one that he gets to play around with because he doesn't teach you the riddles and he just gets them online and pastes them onto your final. This is the one that I'm talking about for Towers of Hanoi. This is what he told us to memorize. And it's in your book. And for me, it's on page 62. For you guys, it might be a little further, a little bit after, a little bit before. But he's gonna say this. He's gonna say if, and then put a blank. Then the from tower equals blank. Else, the from tower equals blank. Then he'll say get next to tower. So what's the next to tower? And you do that same comparison. If, then 2 equals, and then else 2 equals. And for our final, this was only for the odd number of discs. Do you think a partial credit? I heard some questions on multiple parts, and if you get one wrong, the entire question is wrong. So he does give partial credit. So, but if he doesn't, the only time he doesn't that you touched upon is when he mentioned, if he says it in the question, he says, in order to get part A correct, your explanation in part B has to be correct. Meaning, if your explanation in part B is wrong, then part A is automatically wrong. You don't get points for it. But he'll write that for you on the exam. And somebody said it's page 59 in your guys' book. So thank you. Okay. So this is for an odd number of disks. And again, that means n mod 2 would equal 1, and so on and so forth. Okay. We can take a look at this if you want. Oh, and then you have to say what the candidate is. Okay. He's not going to make you write the entire. Okay. We can go over it. No problem. Let me just pull it up in my book again. Yeah, but this was an easy 15 points on the final that he usually otherwise wouldn't give out. Okay, let's do it. So we start with our first comparison. Right, we initialized all of our towers. We did pushback, initialize. We have from equals 0, 2 equals 1, and the candidate is 1, right? These are just the towers that we have now. So we do the comparison. We say, here it is. We do the if our current 2 tower plus 1, meaning 1 over mod 3 dot back, right? The top element of it is less than t sub 2 plus 2 mod 3 dot back. Then what's our from tower going to be? Remember, we want to take from the tower that has the smaller disk now. So we want it to be 2 plus 1 mod 3, whatever tower that is. And remember, the reason we do mod 3 is because if we're here and we add 1, and we add 1, there's no such thing as a fourth tower. So we do the mod 3 to keep it in that sort of circle. Okay? If not, if this is false, then the from tower will be 2 plus 2 mod 3. Okay? That's our from tower so far. Make sense? Okay. So again, we checked which tower has a lower ring value at the top. So we can set that tower to be the from tower, which is where our next ring will be moved from. Great. Now, we want to check to see which value from the 2 towers remaining have a higher value, right? Because our 2 tower, we want to put a small disk on top of a bigger disk. So we check which one has a higher value. If the tower closest to the from tower has a higher value, that means we can place a lower value ring on it. So let's write the if statement for this. We said if the from tower we're at right now is less than the one next to it, mod 3 dot back. Then the 2 tower would be the one closest to it. So it would be from plus 1 mod 3. That's going to be our 2 tower. If it's not, then we move to the only other tower available because we want to move the ring until all of them are on tower B, the second tower, this one. I think he calls this A, B, C. So we just say from +2 plus 3. And then we want to talk about the candidate. So the candidate in this case, it's going to be on the top of the current from tower. Okay, it's the candidate ring, as he calls it. It's going to be at the top of the current from tower. So how do I say that? I just say T sub from dot back. And this is exactly everything that was on my final for Towers of Hanoi. How does this change with an even number of discs? So it's a good question. With an even number of discs, let's do this first. We'll do the odd. This is an odd number of discs. So we're able to move right. Meaning, I have my 3 towers, and I know it's an odd number of discs. I keep going right, and so on and so forth. If it's odd, even, sorry. If even, I move the opposite way. I move to the left. Meaning I have these. And I move to the left. So I start here. I automatically move to the left. And left. And left. And so on and so forth.
So in a way, we check from +2 mod 3 first, if it is even.
Exactly. Yeah. But he didn't he didn't ask us for even on the final, but he could ask you guys for even. Yeah. But if you have the code for it that you worked on to submit to your lab professor, then knowing the 2 conditions should be fine. Any other questions about Towers of Hanoi iterative? Okay. So we can move on to the next topic I had here. The rat class. Okay. So there was one question. What is 6? There was one question that he had about the rat class, and it was very similar to the one we did in class. No fancy 8 queens. There could be a variation of 8 queens, like 8 queens, 1D, no go 2 is just writing the OK function again. Something along that line. So in class, he asked you guys to write the operator plus function for the rat class, correct? Tell me if I'm mistaken.
We went over it together, I think.
You went over it? Did he tell you to write it as part of a lab assignment or no?
I think he was saying something about that in the last class.
So the rat operator plus, right? The idea is our computers can add 1 plus 1 and we get 2. It can't add 1/3 and 2/5 and get whatever the answer is. Can't do that, right? Because these are rational numbers. And we don't have rational numbers in our computer. We have ints, doubles, and so on and so forth. Now, here's a rat operator plus method, which is found within a class. Here's a rat operator plus was this rat t, right? He gives you already a rational number t, and that's where you're going to store all the information. So t, the numerator of t is the numerator times r dot d, the denominator of the current rat, d times r dot n. T dot d equals d times r dot d. Okay? Then we return t. So let's work this out together. Say you have 1/3 and we'll use 2/5, just like we did before. The way you do it is you take the numerator of 1, multiply it by the denominator of the other. So this would be 5. 1 times 5. And you add the denominator of the original times the numerator of the other one. And that's going to be 6. So to find the denominator, you just multiply these denominators by themselves. So 3 times 5. And so this equals 15. This is 6, and this is 5, and this is 11. It should be 11 over 15. Now, if we do this the way we learned in math, we find the common denominator, so 3 over 3, 5 over 5. And we get 5 over 15 plus 6 over 15, and that's 11 over 15. Just like that. Okay, so our answers match, so we see that we did this correctly. He's not going to make us do all. So on the final, he's going to make you do, or at least if he keeps it the same, he's going to make you do operator minus. So he's going to say, write operator minus for the rat class. Something like that. Exactly. What does Tn? So the dot operator. The dot operator tells us we're able to access this information from that object. This is a dot operator. And so it says every rational number has a numerator and a denominator, right? And the constructor is what builds it. Exactly. T dot n equals T dot numerator. The constructor is what constructs, builds that object. And so what we have at the end is this rational t. He calls it t, right? You can call it x, y, z, w. Has a numerator and a denominator. In order to access what the numerator is, we say t dot n. So if I were to say c out t dot n, I would get 11. Just like that. Does that make sense? Let me see if I didn't miss anything else. Okay. Okay. So he'll say write the operator minus for the rat class, right? And I think he also gave you the operator equals for the rat class in your book. Let me see. One sec. Okay. So you have rat operator minus now. And again, it's the same idea with, don't remember anything about equals. Okay, he might have not done that. Say what one more time? Let me see if I have the equals in my notebook. Oh, I remember one more thing on the final, by the way. We'll come back to it. It's structs. Okay, I'm going to continue with this. Somebody wanted me to say something one more time. Let me know what it was, and I can repeat it for you. No problem. That's weird. I saw an operator equals. It's the same idea of finding out subtracting fractions and adding fractions are essentially the same, right? You have to have the same common denominator, and then from there you're able to move on. So here's the answer to it. Somebody actually mentioned it in the chat. It's just changing the minus to the plus to a minus. So you still have the rat t. You do the numerator equals the numerator times the denominator times the numerator of the original. We set that equal to t. Okay. You do t dot d times r dot t, and you return t. And that's essentially just the answer. Any questions about classes, the rat operators, anything about this object-oriented programming aspect that I know he only touched about two classes on? Yes, this one you definitely have the right to write the code, but it's the code for a function. You want me to trace the program for operator minus or operator plus? Okay, so let's go back to the operator plus. And we'll do it together. So every rational number, remember, has a numerator and a denominator. So we create rat t, and t has to have a numerator and it has to have a denominator. So this is going to be n, this is going to be d. And so now the way we do this, the way we add, rather, rational numbers is as follows. Let's take two numbers. I'll say 11 over 17, and I want to add that with 3 over 4. Okay? So the way we do that is we would typically multiply both sides by 4 over 4, multiply this by 17 over 17, and then add the numerators after they were added, right? Essentially what he's saying is you can just skip that step of all this extra work, and you can just take this 3 and multiply it by the 17, and then take this 11 and multiply by the 4, then take the 7 and multiply by the 4. The 17 and multiply by the 4. Essentially, 3 times 17 is going to be 51. Then you have 4 times 11, which is 44. Add that together, that's 95. You take the denominators, 17 times 4, and that's going to be 68. So then when we return t, we return 95 divided by 68. And that's what our answer is going to be. Does that make sense? Great. Okay. Any other questions about rat operators, plus, minus? Do we need to worry about printing the rat? No. As far as I know, he never asked us to print the rat. He also probably didn't teach you how to do that. He probably mentioned something along the lines of you'll do that in 212. So he didn't really teach it to you. But let me see if I'm just looking through my notebook. No, I don't see anything about printing the rat. No. Okay. Okay. Cool. Okay. Any other questions about the rat class? Okay. If not, let's move on to structs. He touched upon structs with you guys, right? Okay, perfect. Yeah, we did structs. Okay, good. So a struct is basically the same thing as a class, right? It can create an object, and I think the only difference between the two is that everything in a struct is automatically private, and everything in the class is automatically public. So you have to say something. If you don't say something in a class, it's considered public. If you don't say something in a it's the opposite. Okay, it's the opposite then. Never mind. So it would be everything in a struct is public and everything in a class is private. Okay. Let me just pull up the example that he gave you guys. I think it was with Bob, right? Student Bob. He gave you guys. Let's see what it is. And then we can do memorization with Fibonacci. Yes, it is. And then also okay, just so we don't forget that. Let's see. Here it is. Okay, for me it's on page 53. It might be on a different page for you guys. I'm not sure what you mean by private has to be before public. Like when you're writing code? Okay. So we have here that we create a struct student. And this student has a name, they have an address, they have an ID number, they have a GPA, and they have the number of the semester that they're in. Yeah, I was wondering if this, for you guys, it's page 51. Okay. Right, Phoenix is right. Yeah, I was wondering if the stuff that I probably had to come. So they're not interchangeable, but it doesn't matter. The order doesn't matter as long as they're different variables. Meaning if you say if you say public int x, and then you say private int x, we're going to use the one that's the most recent one. So x is now private. But if you say private int x and public int y, it doesn't matter because these two don't affect each other. Pointer and hexadecimal problems. Let's do it. Okay. Okie dokie. Okay. So he can create something along the lines of this, and then now you can say student is now a type, so you say student Bob. And now I want to say student Bob is a 2D array, right? It is, sorry, I have an array of students, and I call it Bob. Oh, you know what? No, let's not do 2D. No, you know what? Let's make it 2D. Yes. Then, and I want to say that there are 5 rows and 100 columns. 5 by 100. Yes. Okay. So the question is, how big is CS211? That's the question that I have. So let's make this a little simpler. We'll say 10. So we want to make it 5 by 10. So let's see if we can do that. That's 1, 2, 3, 4, 5. That's 1, 3, 4, 5. Okay. Depends on the instance variables. Not quite, no. We have a student in each one of these boxes, rows, columns, etc., right? There's a student everywhere in these. Now the question is, I have 5 rows, 10 columns. That means I have a total of 50 students. Right, just 5 by 10. I have to multiply it by the number bytes of 1 student. Now the question is, how many bytes is a student? So we go back up to the struct and we see what a student is composed of. So it has a string name, string address, string ID, a double GPA, and an int semester. Now the question is, how much does all of this weigh? So, just give me 1 second. Okay. So how much is a string? What's the value of a string? Who remembers? No, not 32. 8. 8. So a string is 8. How much is a double? 8 as well. Excellent. How much is an int? 4. Perfect. Excellent. Good. So a student is a type of 8, 16, 24, 32, 36, bits. And so we do 50 times 36. And let me use a calculator for that. 1,800. And so that's how much 50 students are. One student is 36. This array gives me 50 students. This array has 50 students everywhere. And so I have 1,800 bits being used. Any questions about this so far? It should be bits. Oh, I wrote bytes. It should be bits. Okay. I'm going to assume that's it for... So we counted the array already when we said it was 5 rows and 10 columns. To count how many total students in the array, you just multiply 5 and 10. And that's 50. That's where we got this number, 50 students. Each student is 36 bits. Multiply those two out and you get 1,800.
Can you explain why each student is 36 bits again?
So up here, when we created the student, there's a string name, that's 8, right? Because it's string. So that's 8 each. This totals to 24. Then we have a GPA, that's a double because we want it to represent a decimal. So that's another 8 bits. And then you have the semester, right? The semester number. Is this your 5th semester? Is this your 4th semester? That's just an integer. It's just a number that should be 1 through 8, maybe 10, or maybe less. Sorry, in between 1 through 10, should be. So that's an integer, and integers, if you remember the size of method that you had to know for your midterm, the size of method will tell you the number of bits something is. So an int is 4. When you add all of these up, you do 8 plus 8 plus 8 plus 8 plus 4. That gets you 36. This is 16. This is another 16. That's 32. 32 plus 4 is 36. Yes, basing it off of a 32-bit computer. If you're not sure which big computer he's talking about, always raise your hand in class during the test and ask him. Vectors. If we have time, I can go over vectors. Sure. Let's do this again. When I do size of string, you get 32. That's weird. I'm not sure why you get 32. Should be 8. I remember he told us in class it was 8. I'm not sure why you're getting 32 though. You can show it to him and ask why, but yeah, for the final it should be 8. It's not 32. Okay. Any other questions about this example? Okay, so if I have now an array, let's create another one. We'll say struct, and now I'll say CS211. So this is my struct. CS211 has students. It has students. It has what else does it have? It has students, and students already take care of name, address, IDs, GPAs, and semesters. And we also want to say string professor. We want to say, should we capitalize students? No, this is a variable. You could capitalize it if you want. This is a variable. Right? It's a variable name. You don't necessarily have to capitalize variable names. Then you have string professor. Who's your professor for CS211? String class room. And then int course ID. Okay. And then maybe we want to say int section as well. Now, I made this one a little bit more complicated. Say I have CS211. Let's see. This is what, fall 24? Yeah. And there are about 300 students in the class. Okay, I declared that. How much space does this take? Okay. So who wants to see if they can do it? Or should we do it together? 60. It is building upon the last struct. Excellent. Okay, Gurpreet, how'd you get 60? Let's see that. So you're saying this is good. This is 36. Excellent. Good. This is where you had to just remember. Students weigh 36. Excellent. 36. And then this is a string, so that's 8. This is 8. This is 4, and this is 4. So total this, that's 24. Add those two, that's 60. Excellent. Perfect. Eric, you got it. I'm trying to think. How did you get 9,600? Yeah, but good, because we have 300 entries, 300 CS211s. That means we have 300 multiplied by the total, which is 60, and that's 1,800. Right, 18,000. 3 zeros. Yeah, 18,000. Good. Okay, so I'm assuming everybody understands this a little bit at least. The 36 came from student. Student was a type that student was an object that we created, and where is student? And we said that a student equals 36. Yes, student from the previous struct, exactly. The idea of continuously creating objects is that you're always able to reuse them, so you don't always have to look back for them in a way, if that makes sense. Okay, so far so good. Yeah, so you'll need to write the value for it. Exactly. Exactly, yes. Perfect. Any other particular questions? Right. Okay. Good. Let me see if I can find this question in my packet really quickly. Which table? Like how to get 50. 50 was just the array, if that makes sense. I can explain it to you right now again. Okay, 1 second. Okay. So 50 was just how I got my array. I told you it was a 5 by 10. So I came up with this. 5 rows, 10 columns, right? You just multiply the rows and the columns of the array and you get 50. Was there any debugging questions on the final? No. On my final, there wasn't. Yeah, it's provided exactly. If CS2, there's outside student I can be used. No, it could still be used. I'm not sure if you guys learned about inheritance, but if CS2 is outside the student, yeah, it could inherit something. I made it a little more complicated, but just in case if he puts something like that on, at least you guys know about it. Yeah, no, mine didn't have any debugging questions. I also don't remember pointers being on mine, but that could be just because I'm forgetting it. Let me think. Okay. Trying to think. Okay, Waxman didn't even, oh, he didn't go over inheritance? Okay. Oh, he did? I don't know if he did or if he didn't, but okay. Very briefly. Okay, so very briefly to Professor Waxman means he's probably gonna put it on the exam. I don't know, but let's go over functions, pointers in functions. So one part that he tells you about is syntactic sugar. Let's see what we just did right now. We just did structs. Let's do this portion. If we have time, I'm gonna get to a midterm review again. Integration meaning you mean that when he used functions as parameters. Yeah, so I know he gives the entire code for that in class, so I can't imagine that he would give it to you on the midterm because it's just a straight memorization. What he does give is I'll show you exactly what I'm talking about. This is what I'm talking about. And it was a little hard to trace. I don't remember if I can still do it, so let's try it together. He gave us a function written in C, okay? So he'll give you a function written in C. Now, what's the difference between C and C++? C++ has syntactic sugar. So if I tell you A sub 1, it'll get you some value, right? Say this is A, and whatever it is, it's 0, 1, 2. So A sub 1 gets us 1, right? This is in C++, though. In C, if I use that same array, I can't say A sub 1. This isn't going to work. I have to say A plus 1 dereferenced. That's going to get me 1. Okay? I don't know if you guys remember that, but that's not so pertinent right now. This was the example he gave us. He says int s int star r n. He says if n equals 1, then return star r, else return this one s. Okay, so if I remember this trace correctly, it's just a fancier way of saying factorial. This whole thing is just a fancier way of saying factorial. And we're gonna run through it together just to make sure I'm not wrong. It's just a fancier way of saying factorial. Okay, let's do it. And in the instructions, he should say something along the lines of remember the asterisks has different meanings in different contexts. Okay, so we talked about it before, and just to remind you, it can either be dereferencing, it can be be multiplying. What else can it be? What is this? Yeah, if I have time, I will go over it for you, sure. It's dereferencing, multiplying, and am I missing something for this? Oh, pointers, that's what it was. Initializing a pointer, initialization. Okay. Great. So he'll tell you this. He'll say, here's the function. He'll give you something. Pretty sure. And then he'll say C out. Okay, if I'm remembering it correctly. Let's see. Okay, let's try running through this. So you initialize, this is where we initialize a pointer. Right, so it's taking in an address, essentially, and then n. We don't know what n is, really. Just know that it's the second parameter that's there. That's all we know. It's the second parameter. Then we check the condition for the second parameter. In this case, it's false, so we automatically go to the else. And we see that it's a recursive call, okay? Because it uses the same function name as it did before. Let me use the function name in blue. Okay? Now, the question is, what are these stars? Who can tell me what these stars do? There's one in dark blue and one in light green. Tell me what the dark blue star does. The asterisk. Excellent. It dereferences. Perfect. What is the... Good. The light green does multiplication. Perfect. Good. So it dereferences R plus n minus 1. Now, remember what I just told you before. In C, this box over here. In C, when you have two things that are added and then dereferenced, it'll get you a value in that array. So in this case, n is 3. We subtract 1, that's 2. 2 plus r, r being the first parameter. And the first parameter here is an array, which is good. So it's really saying a plus 2 dereferenced. A plus 2 dereferenced is 30. So here I'm saying 30 multiplied by S of R comma, and then it was 3, now it's 2. Okay, and we follow that same pattern, We get the second one, second input, that's going to be 20. And we'll run through it right now. I have, this is going to be false over here. This is going to be false. And so I go to the else statement again, and I return the dereferenced value, which is 20, right? We get R plus 1 dereferenced. Yeah, R plus 1 dereferenced. Multiply that by S R comma 1, because N was 2 now. And so this gets us the 10. This portion over here gets us the 10. And then that's what we multiply by the 20. And the 20 is what we multiply by the 30, because that's what this equals. So we essentially get 30 times 20 times 10, which is, okay, it's not the factorial, rather it's multiplying the array from the end to the beginning, right? From the last index all the way to the first index. And so this is just going to be 6 with 3 zeros, 6,000. Okay? That makes sense to everybody? Okay, great. I'm glad. Okay, so something along these lines. You see, you didn't learn C, you learned C++, but he taught you the idea with pointers. And in the midterm review, we went over what is the context for the asterisk, right? Multiplying, initializing a pointer, dereferencing, and you're going to have to understand that through this, right? So again, just to go over really quickly, if the asterisk is near a data type, then that means you're initializing a pointer. If that asterisk is around parentheses, you're most probably dereferencing. And if it's in between two things, right, not just one thing, in between two things, you're probably multiplying it. Okay. Any other questions? Sure. I can repeat that for you. If the asterisk is next to a data type, you're probably initializing a pointer. If the asterisk is near parentheses, you're probably dereferencing something. And if the asterisk is in between two things, then you're probably multiplying. Okay, there are exceptions, edge cases too, which is why I say probably, not to say this is always what happens, but I just want to let you guys know that that's majorly what the cases are. Yeah, it should be the same thing as dereferencing. Should be. Okay. Okay. Fine. So yeah, he can give you something similar to this. He could actually make a factorial question out of this, and it wouldn't be wrong. Okay. Let's see what else I have that I'm missing. Okay. Okay, so I don't remember there being Fibonacci on the test, but there was a question about delete and now and new. So let's go over that really quickly. We'll do that over here. Let's start with what does new mean in object-oriented programming? You started doing it with the n queens problem, if I remember correctly. Allocate what? Dynamic memory. Good. So we're allocating an unknown amount of memory. We're just saying allocate some new space in memory for me. Good. Now, our computers can only hold a finite amount of space, right? We don't have unlimited amounts of space in our computers. And so the question is, why do we use delete? Excellent. Good. Prevents a memory leak. Now, does anybody know what a memory leak is? Okay. So, because I know he says that in class, but he's not always super clear about what memory leak means. So a memory leak is just a fancier way of saying prevents memory from overloading the CPU. That's a fancier way of saying prevents you from running out of memory and to lose access to other pieces of memory that you might need later on. Okay. If you have a memory leak, your computer is probably going to overheat. It's probably going to slow down because you have all this useless use of memory. Thank you, Leo. Useless use of memory on your computer's hard drive that is no longer needed. Yeah, if you don't do it once, it would probably be fine. But remember, you're probably going to be using your computer for a lot of different programs at one point. If you don't delete all of them, then you're definitely going to experience the memory leak. Okay, that was what I had for new and delete. I can't remember anything else being there. We can go over memorization. Let me pull that up really quickly. Okay. So, can we fully go over another riddle? I don't remember any other riddle questions for Waxman's class. I only remembered those two. The riddle ones, just so everybody knows, are usually the ones that everybody skips because it's not it's not like something that most people know. His curve for the midterm, I think people do better on the midterm, is, which is why it's worth less, is square root times 10. So here's an example. If you got an 81, square root that, that's a 9, multiplied by 10, that's 90. Your 81 turns to a 90. On his final, because it's harder, I heard it was square root. So say you got a 64, square root, and multiply it by 12. So this is 8 times 12, that's a 96. So your 64 turns to a 96. Can show the curve. Let's see. I didn't understand like. Oh, you want me to show that? Yeah, sure. Say you got a 64 on the midterm. So you're gonna square root that. That gets you 8 multiplied by 10. That's 80. If you on the final get a 64, that's 8 multiplied by 12. That's a 96. It depends on how the class does. If the class does really, really, really bad, I've heard him even having a square root times 15. But that's not such a good indicator that the class did very well if he has to multiply by 15. Okay. So should we do the where is it? Memorization? The final curve is usually better than the, but it's also a harder test. It has more information and it's worth 40% of your grade. Okay, let's do the memorization. So the idea with Fibonacci, is that, say Fibonacci of 6. Let's go Fibonacci of 6. We have to constantly figure out the Fibonacci of the previous one. So Fibonacci of 4, Fibonacci of 5. Then Fibonacci of 5, I have to figure out Fibonacci of 4 and Fibonacci of 3. And here I have to do Fibonacci of 3, Fibonacci of 2, here Fibonacci of 2, fib of, no, they have to give you the first 2, right? Yes, the first 2. So this should be Fibonacci of 1. And then this is 3 and 2. This is 2 and 1. This is 2 and 1. So you see how many times I've calculated, let's do 3. Fibonacci of 3, calculated it multiple times. Same thing with Fibonacci of 4. Now this is just with the example of 6, a Fibonacci of 6. If I decide that I want to do Fibonacci of 100, I'm going to be calculating Fibonacci of 3, Fibonacci of 4, Fibonacci of 5, so many more times than I would like. So the question is, how can I simplify this so that I'm not wasting computer resources on continuously finding out what what a Fibonacci of X would be if I already solved for it? Anybody remember? I think I actually said the answer for it before. Exactly, through memorization, and we use the array. Excellent. So the idea is, I'll create the regular title line in Fibonacci int n, and I want to do something different now. I'm going to use this keyword. I'll put it in blue. Static. Okay? Who knows what static means? Good. It doesn't change. Do you know why it doesn't change? Meaning the technical reason why it doesn't change. No. You can reassign. I think you're thinking of const. Const, you can't reassign a value to it. Const is like a promise to the computer, the compiler, that you're saying, okay, I'm leaving this as 3.14. If I say const double pi equals 3.14, I made that promise that it stays as 3.14. So static means it doesn't change because the variable is not kept on the runtime stack. Okay, which means it's kept off the runtime stack somewhere in the heap, and so it's not affected by when the values are changing. Okay, that's just something that you guys should probably know. We say the regular if n equals 1 or n equals 2, return 1, right? The values of the first two will probably be 1. And then we say if memo of n, right? If the nth number, right, 2, 3, 4, 5, whatever we're looking for, the nth position, is found in our memo array, meaning it's going to be greater than 0. It's going to have some value that was already solved for. Then we're just going to return that value. Memo sub n will return that value. If not, then we're going to have to solve for it. We're going to do int return memo sub n, and we're going to assign to this the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So how does that compare to our picture here? Once I've solved one time for Fibonacci of 3, I no longer have to solve for it. It'll automatically just be plugged in constant time. Okay? Automatically be plugged in. So there's no resolving. There's no resolving here either for that. Automatic. And the same thing, it's going to be plugged in just like 1 and 2. Does that make sense? Okay, perfect. Any questions about this? The last part. Club. The last part. Can you explain which last part you're talking about? You can, so to answer your question, is it n equals 2 or n equals 0? It depends. If you want it to be the 0th position in the first position, you can do that. If you want it to be the first and second position, it's fine, as long as if it's the first two numbers. So if you want the first two numbers to be 0 and 1, that's fine. If you want the first two numbers to be 1 and 2, that's fine. Doesn't matter. As long as you establish that it's the first two numbers that we're talking about. With memo 100. Yes, that initializes all the elements there to be 0 because of my, and I do that because of my if statement, where I want to check if the value is greater than 0. If I check that and I don't set everything equal to 0, the compiler may override it in some way and actually assign it a value that is greater than 0, just as a placeholder. And I think you should learn more about that in 316. Principles of programming languages, that sometimes the compiler will override it to quote make it seem like it makes sense for it. But yeah, that's why we initialize everything to 0. I'm gonna assume that the last part you mean is that what I circled in green and red and orange is that we no longer have to resolve for those specific parts anymore. I can just plug in. I solve for it once, and then I store that number in the memo array. Right? I memoized it. Then I just look through the array. I say, give me memo of 3. Memo of 3 will be plugged in, and because I already solved for it before. And then there's nothing left for me to do. Yeah, you'll probably have to write code for this one, either that or an explanation or both. He might make you do both for this one. Again, that's only if it shows up. He could have changed his final. Okay. Let me see what else we have left to do. So dynamic we did. New and delete. Okay, pointers and hex addition. Okay, and then we'll call it a day. Okay. So Give me 1 second. Okay, so let's talk about hex addition. And I actually think we went over this for the midterm, but again, that's the hex addition is something that you learn in CS240. If you haven't taken it, don't worry. He gives you a chart on the test that you use to add these numbers. So let me see if I can addition. He should give you this chart. Let's see. Yeah, here it is. Let me see if I can copy it. There. Okay. Okay, do you guys rather vectors or hex addition? Which one would you guys rather? I'll do whichever one you guys want. Hex, vectors, hex is easy, vectors, 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 vectors. Okay, I'm seeing a lot of people want vectors. Yeah, a lot of people I see want vectors. Okay. Okay, fine. So let's do, I guess, vectors. Okay, fine. Let's do vectors. If you want hex, there are many. It's very simple. There are a couple of videos on YouTube that you can easily watch for it. And you can use just the chart that I put in the comment section. It's very simple. You just look at the row, add it with the column, and then wherever they intersect, that is what you have. Okay. What about vectors would you guys like to go over? Okay, so let's talk about the three methods they have. So vectors are, I know he's not gonna ask you about 2D vectors because I don't think he even taught you guys 2D vectors. So, okay, so I'll tell you guys what you should know. You should know the three methods: dot pushback, dot pop back, and dot back. These are the three most, obviously vectors have many more, but these are the three most important that you need to know. Pushback adds to the end. Back tells us what's at the end. And pop back removes what's at the end. Okay? So that's pushback, pop back, and back. Now, what do you mean the front as well? It doesn't remove anything from the front. The back meaning the top. So say I push back the green, and then I push back this orange, and then I push back the yellow. You can't see the yellow so well, but I push back the blue. Then I push back the purple. Then I push back the red. And then the black I push back. So say I call this vector J. If I say J dot back, it's going to tell me black. If I say J dot pop back, it removes this black circle. And now if I say J dot back, it'll give me the red circle. Oh, thank you. Okay. If I say, and then I can say J dot pushback, j dot pushback, let's say this squiggly green. So I add a squiggly green now to the top. Okay, and you can play around with the vector. The idea of the vector is that it's not static. It doesn't stay the same like an array. I'm always able to continuously grow it and shrink it. And that's why you use it for Towers of Hanoi, because n disks are unknown, right? You let the user pick the number of disks. So you want to say, okay, the user can pick 15 disks. And so that's an odd number. You move to the right first because it's odd. And then you're able to make a vector of size 15. And you pop back all of the disks onto the first one and move on with that. That's all you really need to know for vectors, plus Towers of Hanoi. The Towers of Hanoi code, I highly, highly, highly recommend that you guys know. Properties of vectors, just like I said, is that they are not static like arrays. They can grow or shrink depending on what the user or the coder wants, the programmer wants. And then these three methods. Those are the final things that you guys should know for this test. When's your test again? On Monday or Wednesday? Wednesday. Okay. Yes, exactly. Vectors are dynamic. Perfect. Okay. So I can stay on for about another 5 minutes if you guys have any last minute questions about the test itself, what to expect, anything I should clear up. But if not, give me 1 second. I just have the feedback form. If you guys could please fill that out for the Learning Commons so that we can do this again for 211 and 212 next year. Why is this not sending answer? So usually on the test, there's about 15 questions. He gives you guys more questions for these tests, for the final especially. I think you guys also have more time. You guys actually have a good 2 hours for this test. What questions that were on the... No, if it was on the midterm, it won't be on the final. Meaning not the exact same question. You could have pointers on the final that were different from pointers on the midterm, for example. Something along those lines. You were serious when you said the test is... My lab professor said it was 50% riddles. I thought it was more like 30% riddles. Because the riddles is something that he doesn't teach you. So it's a little harder to prepare for, which is, I guess that's why his curve is also good, and he adds more questions on the final to give you guys more points to balance out the fact that he puts riddles there. But yeah, it's it'll feel like a lot of riddles when you're taking the final. Let me see if I missed any other questions. But yeah, here, if you guys could please fill out the feedback form. It should take like 2 minutes, maybe less. Even it just really helps us with funding so we can keep doing this. But I'll stay on if anybody has any other questions. Yeah, you're welcome. Of course. Thank you guys. You're welcome. You're welcome.
Rui,
All
have
right,
a
good
great
luck
day.
on your midterm on Wednesday. Yeah, for sure.
Thanks, Roy. Have a great day.
No problem. Have a good one.
Actually, I had another question. It was
Yeah.
regarding if we just based on this review, like if we go through this, like would it be enough for the exam? Or
It
what
should
else
be
do you
enough for the
recommend?
exam, but if you have, I would say still go over your class notes just in case if I missed something, and ask your lab professor. Maybe they know something else that's going to be on the test as well that I might not know.
All right, no problem. So this review like probably covers everything. Probably for me, I guess.
Covered everything that I could. Yeah.
Yeah.
Can you please?
Yeah, thanks by the way.
Yeah.
Thanks
of
so
course.
much.
The recording should be uploaded by tomorrow. Once I end the Zoom, I sent the link to the Learning Commons and they upload it to the website. Let's see this. Manjot, I'm not sure if any of these were on the final. They don't look familiar to me. It could be that they were, but just not on mine. Could be on a when it was online. Counting configurations. So I had 3 to the 3, so I just did that one by hand. But you would have to do something similar to the odometer example, where it only goes up until that certain number. So if it's 8 to the 8, it's 0, 0, 0, 0, 0, 0, and then up until 7 at the end. And then when you get 7, think of it as the 10 that we do in our regular counting, and it becomes 1, 0 again. And if you know binary, then it should be simple. But again, that's something that you more so do in 240. I don't remember that being on the final exam. Let me also stop recording.